Welcome everyone. This is going to be the first session for the DevOps Masterclass 2022. So today we are going to start talking about DevOps and understand the big picture of why DevOps and what exactly DevOps is trying to do. And then I will show you a snippet of the end-to-end flow of the ideal situation when you start working in the real world, okay? So it's very important that you understand the end goal before we even start doing anything, so that you won't just be doing things, working on Linux, working on AWS, and you don't really understand why you're doing all of that, because there's just so much to do. So I like to give you, first of all, the full picture of what's going on, and then we can go back and start doing things from the beginning, all right? So first of all, there is a code repository called Dare Masterclass. I hope you can see my screen.
Yes.
Okay, good. Let me just move this around. So there is a code repository. So I'm going to send this to you after the class. I'll send it in the Slack channel. So all you have to do is just clone this repository, all right? And you will see a number of folders. So at the moment, there is week 1. So every time we start a new week, I'm going to create a new folder. And then in that folder, you see Saturday and Sunday. So the note for that particular day will be on that date. I'm not sure if I should even put dates, but I'll think about the best way. And this is so that over time, you can always make reference to this. You can go through the notes, you can understand things. And sometimes I'll put code snippets as well. So if you need to copy code, run it, practice it, and see what's going on, all of that's going to happen. But for today, obviously, this is week 1. This is Saturday. By tomorrow, you will see Sunday. And then we'll do week 2, week 3, 4, 5, 6, and all that till we get to the end, okay? And then there's another folder here called applications. So from time to time, I will be putting some code in there to simulate software. So at the moment, the only code right here is for one PHP file, PHP application called the tooling app. And we're just going to use that, simulate a typical DevOps workflow so that you understand what's going on. So, but first of all, let's begin to talk about DevOps. Now, some of you may already know what DevOps is all about, but it's also important that we go through it and then begin to answer some of the questions and doubts that you may already have. Now, I'm going to read out some things and then I would explain and then, carry on till we get to the, bottom. So what is DevOps? Okay. Before I say my own view, does anybody here have any idea whatsoever? Or if you've been asked, what is DevOps? What would you say? Forget about what you're seeing on the screen. Feel free to just say it from your heart, what your understanding of DevOps is. I'd like to hear from maybe 1 or 2 of you guys. Anybody wants to try? And feel free, this has to be a very interactive session. So no one here is smart. I am not smart. So don't feel like, oh, I have to say something smart that others will be impressed at. No. Don't do that. Don't do that at all, okay? Whatever it is, I just want to know to what extent you understand things, and then I can help shaping your understanding. All right?
Okay. Let's do this. So, hi guys. Okay, so my understanding of DevOps is more or less like a platform, a knowledge that bridges the gap between operations, developers and the business itself. From my little research, I understand that when you're a DevOps person, you help with continuous improvements, continuous integration, especially when software, the programmers do their thing, and instead of them waiting for like 3 months or 4 months before they actually upload it or something, there's this always everyday continuous improvements that the DevOps engineer takes, and I don't know, but that's just my basic idea, my raw idea.
That's good. That's a very good attempt. That's a really fantastic attempt because you are spot on. You understand the core of it. Of course, there is a lot more to it, which we will talk about today, but you're on track. Okay. All right. So thanks a lot for that, Femi. Does anybody want to add to that?
Yeah. To my understanding, DevOps is an integration of developers and operations in order to make software delivery efficient, including application as well, efficient, quick, and interactive. That's a nutshell.
Okay, thank you. I like that you made reference to application quick, and that's very true because there's two key words you have to always remember, which is fast and high quality. Fast and high quality. So in my notes, I've actually talked about that and I've made reference to that a number of times already. And you have to always remember that. So it's all about the whole release cycle of software, but making sure that we're able to do that quickly, very speedily, but at the same time, able to produce a high quality software. Because it's one thing to want to quickly do something. It's another thing to have that thing done quickly, but what's the quality? How good is what you produce? Because what's the benefit if you're able to release software quickly, but your software is full of bugs and people are not able to use it, which is not very good. I was looking at one company on Instagram. I'm not going to mention their name, but it's a digital bank in Nigeria. And in the comment section, I was seeing a lot of people complaining about, we're not able to do this, we're not able to do that. I keep getting logged out and things like that. And I just smile. And this is a typical situation where software is being released, but the customers are complaining, and that is not very good. So that's one of the things that DevOps is here to solve. So we're going to start going through this and we're going to break it down very well today. So let's start with the first paragraph here that says a concept that has emerged as a result of the failures of traditional software release methods. So that means there is a release method existing already before DevOps came about. Okay. Now it is an intersection of development and operations. So the two main arms of IT that make software products available to end users. So if you have been working in the software industry for a while, you will understand that there's usually the software developers and then the operations. So if we say operations, because someone mentioned the business when he was talking about DevOps, meaning we're actually not really talking about the business side of things here. We're still talking about IT. In the IT department, there is the operation side of things. There's also the development side of things. So when we say development, we're talking about there's the project manager, there's tester, there is, what do they call them? There's a number of people involved in software development, front-end developers, back-end developers, even UI, UX, they're all part of the software team. But when we talk about the operations, we're talking about the people that make the software to run. Because when developers code the application, that application has to run somewhere. And usually it's going to be on some servers. So if you're working in a Microsoft shop, then that means it's going to be deployed on some Microsoft Windows servers. So Windows 2012, 2016, Windows, whatever, they have different versions of Windows Server. So they deploy it and then they use some other tools like IIS to deploy it and the whole thing start working. And then as part of the operations are the people in terms of the in charge of the network. So you have network engineers that ensures that these servers are connected together. You also have the storage administrators that ensures that there is enough disk space to support these servers. There's also the database administrators. Those are the people who ensures that the database is active, is live, there is backup from time to time. If there's any failure, they're able to bring it back to life. They ensure that there's high availability, disaster recovery. All these has to do with operations. So the developers, they have their own incentive, which is to always develop new features. And then the operations guys, they're always there to ensure that the operations to get the software running and available to the end users is taken care of. So the network admins, the storage admins, the database admins, the server administrators, all these guys, they all form the operations side of things. So if we say operations in IT, we're not really talking about the business side of operations. We're still talking within the IT space, okay? So that's that. So we said there's the traditional software release methods. So what is this traditional software release method? Let's go to the next paragraph here that says, traditionally, companies use the waterfall idea to release software. So what that means is when there is a software project that is about to start, they take the requirements, they code the whole thing, but they wait until the end before they release it to the end users. That's a waterfall approach, okay? Now, it may take them 6 months, it may take them 1 year, whatever time it takes them to complete the entire software development, that's when it becomes available to the end users, all right? And doing that, there is a particular flow, which we're going to talk about now. DevOps still goes through the same flow that the traditional method goes through. But each of those steps have their own challenges. They have a lot of blockers, and those blockers is what DevOps is there to solve, all right? Now, if you think about this, since it is an intersection, because if someone says intersection, that means if you have two lots and there's an intersection, that means they come together and then there's a part of it that is common to both of them. If you've done set in school, for those who are a math guru among you guys, intersection is the common part out of two lots. So there is the outward part that is not common to them, but the intersection is where the common, right? So intersection there means that the development and operations come together and become DevOps. And that's why they say Dev and Ops. But it also means that there is a part of development that is not DevOps. And there is also part of operations that is not DevOps. So it's just a certain arm of each of these sections that has been brought together to consider for DevOps. And this would answer a question from a lot of people. A lot of people ask me, oh, but Larry, if I want to do DevOps, do I have to be a programmer? Do I have to be able to write code? And that intersection answers that question because you're not a developer. Okay, you're not a complete developer. So that means there's some code that you will write, but the actual software code is not your work to do. So you're not going to be expected to be a Java developer or a HTML developer or CSS or JavaScript or PHP or whatever. If you have those skills, that's fine, but it means that you are not a core developer. Does that make sense? So DevOps is just an intersection that brings both development and operations together. So there's also a part of operations as well that you are not expected to have deep knowledge in. It's just like having basic knowledge in development, basic knowledge in operations, and then becomes DevOps, okay? But we'll get into more of the details soon, and you see what I mean by you don't need deep knowledge in certain things. So for example, you're not expected to be a core network engineer if you're working as a DevOps engineer. However, you're expected to have some basic networking skills. If there's issues with the network, you at least understand the flow of network and you can think through and understand how to troubleshoot things. Database administration, you are not expected to be a database administrator. However, you should be confident enough to work with databases. You can log onto a database, you can create a database, you can create a user, you can change password, you can do some basic things. But when it comes to going into the core of writing SQL or doing performance tuning on an SQL code, you're not expected to do that. Or storage administration. Yes, you should have understanding about how certain network storages work, how certain configuration of maybe a storage attached network or all those kind of things work. But it is not going to be expected of you to sit down and start implementing those things. Okay. All right. So now that you know that, okay, that's okay. At least it just means you are a jack of all trades. That's basically what DevOps, being a DevOps engineer is. You're just a jack of all trades, master of none, right? You have knowledge about a number of things, but you're just not the core of those things, okay? Now let's go through the typical release process and what the traditional release process is, because DevOps is not here to change the release process. All right. So there's two things we've mentioned now, the release process and the approach to a release, to a software project, because there's two different things. Think about the approach as the project management side of things. What is the style that companies usually use to manage a software project? And that's where the waterfall that I mentioned earlier on comes in. So which is, there's a software project, they start developing the whole thing, and then they wait until they finish before it becomes available to the users. So that's just like the project management side of things, right? But the release process itself is the same, whether in the traditional way of doing it or in the world of DevOps. The release process usually starts from having an idea. So a company has an idea of a project, of some software products that they want to develop. Then they engage the business analyst. Okay, so that's the very first stage. You have an idea and then you begin to gather requirements. Who are the business analysts? So these are the guys who are going to help you take the idea into technical requirements. They produce all sorts of documents. These documents, some are technical documents. They have some, they call them functional requirements. There are non-functional requirements. They basically just document everything, all your idea, they put it down, how things are going to flow, what's going to go from one place to another, what's going to connect to what, all those kind of things. They take the requirement, they put it down on paper, and now we have a requirement to deliver something, right? Then the software developers begin to code. They take the technical requirement and then they begin to code the whole idea, put it into some software code, right? And then we have testers who will write test cases and test this software. So we have a software, now the developers have worked on it, but there is a huge chance that the code is going to have some bug, because those bugs, it's just normal. It's not, it doesn't mean that the developers are not good. It doesn't mean that they don't know what they're doing. Even the best developers do write software that has code in it. And that's where testing comes in. You cannot have a software project without going through proper testing, okay? Then the next thing comes the operators, the systems administrators, the storage administrators, the DBAs, the network admins. These are the guys that prepares and configures the servers and the databases. All right, so this includes security, firewalls, installation of dependencies. All these things is what the operations guys are going to do. So you see, developers have done their bit, testers have tested the application, but this software has to run on some servers somewhere. You can't take the software and run it on your laptop. Laptops are not servers, because this is another thing some people get confused. But you're talking about servers, but how does it differ from a laptop? Well, the difference is, first of all, they're both computers, but one is optimized for a huge amount of work that your laptop is not optimized to do. If you're using Windows laptop, for example, you can relate with the fact that you can't have your Windows on for 3 months without it struggling at some point that will require a restart. But servers are optimized to run for a very long time without the need for a restart. And you can imagine a company like Facebook that has, is it billions now of users all over the world? They have huge computers running their application that advertisers go there to post their adverts. Regular users go there to post pictures and download pictures and make comments and do all those kind of things. So you can imagine all that kind of thing cannot be running on a laptop. Okay, so this is where servers come to play. So servers, and in most cases are Linux servers. So they don't have we call them GUI, which is the graphical user interface, like where you can right click and copy and paste and do those kind of things. You see, those GUI, they come with extra overhead that causes your laptops to need restart from time to time. But typical servers like Linux servers do not have GUI to them. They only have a black terminal that allows them to run for a long time. So they don't have all those extra overhead that causes it to crash. Now, am I saying that servers do not crash? Well, no, servers do crash. There are several reasons why servers can crash, but a server would not just crash on the same kind of problem that a regular laptop will crash upon. Does that make sense? So these servers are really, really heavy and heavy duty, and they can do a lot of things. And why are we talking about Linux servers? Why are we not talking about Windows servers? Because Windows servers can pretty much do the same thing that Linux servers do. But the only reason we talk about Linux a lot in the world of DevOps is just because most company applications run on Linux. And the reason for that is just because Linux is more powerful, is much more secure, and companies have just come to love it over a long period of time. And above all, it's free. Windows, you still have to pay license for it. With Linux, you don't get to pay any license except you want support. You pay some companies that position themselves to support you. So like Red Hat, for example, they sell support license, but you can use the servers for free. So they have open source version, which is the CentOS, which you can actually use in production without worrying about any license. But you can't do that with Windows because you have to pay Microsoft cost for license, So that's why most DevOps jobs will require you to have Linux skills. And remember when I said initially that the entry point to your learning journey into DevOps is Linux. So you have to be big on that. Even after this course that you've gone through this program, you have to keep on learning new things about Linux. You just want to be able to be much more confident in Linux. The more confident you are on Linux operating system, the better engineer you will be. All right. So now that we know that we go from idea to having technical requirements, to developing the product, to testing the product, and then to getting the sysadmin guys and the operations guys to prepare an environment that the application is going to run. The next thing is basically to take the application and just deploy it onto those servers and begin to use it and make it available to users. And of course, it doesn't end there because you have to then begin to monitor it after it's been deployed to production servers. You have to start monitoring it, making sure that make sure there are no bugs, and making sure that, for example, how is the system responding to high user load? So now we have it in production. Maybe today, the day of first release, we had just 100 users using the system. Then next week we have 200 users. And then all of a sudden it's Christmas time, we have like 1 million users. You know, we have to keep on monitoring this so that we know how people are using our system. By the time the load begins to increase, there is high chance that if the servers are not properly configured, servers will start crashing and customers will start seeing errors, and things that used to work before will no longer work again. And that's why it's important for monitoring to be put in place, so that the operations guys, they are the ones that do this. Developers have done their work and that's it. They don't monitor it. The operations guy, they set up monitoring, they keep on monitoring the system. They also make sure that any kind of malicious attacks are being looked after as well. Because when you're live, there are people who are interested in stealing your data. They want to steal data of your customers so that they can hold you ransom to come and pay money. You know, that happens a lot of the time. Sometimes I heard that Sony was hacked. Those who play games will know this, you know, and this happens a lot of time where companies are being hacked, they're being targeted. And this is where the operations guys shine a lot. So the network guys, the security administrators, they keep on monitoring the system to ensure that these kind of things will happen. And then are the disks filling up? You know, remember I mentioned about storage administrators. They also monitor all these things, making sure that you provisioned 100 gig today, by tomorrow it's already filled to 80 gig. Before you know it, it's filled to 100 gig. And when there is no more space to write data, applications are going to start failing. So if we don't monitor these things, the fact that you deployed it and it's available to users will get messed up really quickly. Now, is the CPU and memory under or overutilized? So you want to make sure that, yes, there are users using it, but if you provisioned, let's say 64 gig of RAM, and you notice that for the last 6 months, the usage is just 4 gig, you are actually wasting resources that could be used somewhere else. So you want to make sure that you are not underutilizing things and you're also not overutilizing things. So if it's a situation where there is a huge spike and you look at the chart and you can see that CPU is spiking up, and when CPU spikes up like that, it gets to a point where users begin to experience slowness. They click on the button and it's just taking its time to load. You know, that's to tell you that things are happening on the servers that it's just not working fine. Now, there are metrics that can be used to gather this kind of information. So the operations guys are always at the forefront of making sure that they know these things ahead. So when they see those spikes, they know what to do. They decide to scale the infrastructure, maybe add more servers, or maybe add more CPU and RAM, and you know, all those kind of things. As you can see, the developers are no longer in the picture, right? Then, are there new vulnerabilities caused by dependent libraries used in the application? So developers, when they code their app, they use other people's app as well in their own app. And that's what we call libraries. So, you know, say for example, developers are meant to implement a login functionality whereby people go on the web interface and they can put in their username and password to log in. But because this is a common use for literally every application out there, so some people will then write a library that does that functionality, that when it's time for you to start writing code afresh, you don't have to write that functionality. You can literally reuse what someone else has written and just carry on with it. And that's where you will see some code, and then at the top, you will see import. So they're importing someone else's code into their own code, and they are now beginning to use it. This is a dependency, right? And even the dependency that you're introducing may also have its own dependency. So you can see there can be a chain of dependencies. Now, when that happens, it means you don't have full control of those dependencies. And those dependencies can actually be exploited. So someone can put some vulnerabilities into those dependencies. And the moment you import it into your application and you're running your servers, someone can actually get into your servers through those libraries. And that's where you begin to see the different kind of attacks happening. Someone can just go on the browser because they understand the vulnerability of those libraries. They can exploit it and use it to begin to run commands right on your servers through the browser. Okay, they can do that. They get into your servers through the browser, and then they can put some malicious code which gets executed on your servers, and that can extract data. It can push the data to somewhere else. It can get into the middle of your application, and all sorts of things can happen. So operations guys, they keep on looking at things like this and making sure that wherever there are vulnerabilities, they flag it quickly and they respond to it quickly.
This is not working on my.
Is that Chinwe? Are you trying to ask the question? Okay, I think she didn't realize she was not on mute. All right. So I hope this is making sense to you so far. Any questions so far before I carry on? All right, that's good. Silence is good sometimes. It's just that I want to make sure that I'm not throwing you off as we go along. Then are there parts of the software, the system throwing errors, which is not visible to the front end? So this is another area of monitoring, because it's possible that your application is live. You go to the browser, you put whatever.com and it's working. But there may be somewhere within the application that is throwing errors that is not really visible to users. For example, some errors could only come up after you have logged on and you've been logged on to the dashboard. Just like you do on our website, Dari.io, you go on, you log in, and then you're presented with a dashboard. It's possible that maybe a link is broken. You can access one particular project, but the actual site is up and running. So these kind of things are another kind of monitoring that happens, whereby all the pages, all the links are being tracked to make sure that everything is live and working perfectly. So as you can see, after an application is being deployed onto servers, it doesn't stay or end there. There's a lot of monitoring that has to happen. And, it now leads us to begin to talk about the incentives between the developers and the operations. Why do we now have a problem if we have a typical release process like this and it's worked for many, many years, right? Now, finally, as part of the whole release process is improvements to the software. So after you've released, you've been monitoring, of course, there is always new requirements. So users will come, oh, how about you introduce this feature for us? And then you notice that there's a whole lot of users out there that want that feature. Then you go back to the drawing board and you go through the same process all over again. You take that idea into requirement, you get your requirements, you give it to the developers, they code it, they test it, they do all of that. And literally the same process goes on and on and on again. All right. So if we have a process like this that has been working for so many years, then what exactly is the problem? Well, the problem is that with this approach, first of all, it is very slow, okay? Small releases can take weeks. It can take weeks. Major releases can sometimes take months. So what do we mean by major release, minor release, patch release? You get to hear a lot of these things. And that's why here, as you can see, I mentioned here 1.0.0, 1.0.1, 1.4, and you must have been seeing this from time to time when a company says, oh, now we have a release version, this, and that. Well, you should know that if a company is using this style of versioning, they call it SEMVer, which is semantic versioning. Okay, semantic versioning. And sometimes you will see it's called SEMVer. Okay, and what that means is if you have 1.0.0, the last part here, let me see if I can enlarge this. Okay, I hope this is big enough. Now, you see, the last part here is when there are very minor changes. Maybe there's a bug fix. You know, the application has been released and someone has reported there's a bug somewhere, and then you go back to development and you fix that bug and then you release it. The next time you're going to release 1.0.1 because now you fixed a very, very little change. Okay. Now, this is for bug fix or patch release. Okay. Now, the next one is another kind of release that can happen is a feature release. So when your business wants to release a new feature, or let's say they want to release a feature that customers have requested for, that's where the number in between gets to change. So let's say previously there was no, let me think of a feature. Let's think of a banking application, and maybe it's a new digital bank, and initially they didn't have a feature to send SMS after a transaction has happened. And now they've implemented that feature. It's a feature, something that didn't exist before. So you can see there is going to be a change, and now we will have 1.1.1. Okay? Because even if you were previously on, let's say 7, you've done a lot of bug fixes up to 7. Okay. By the time you are changing this feature release here, what's going to happen is this is going to be 1.1, and this is going to maintain the 7, because what's happening is this is the only one that has changed, the one in between, which is a feature release. Okay. And this is feature release. Now, the last one is the major release. Okay, so this one, they call it minor, and this one, they call it patch release. So patch, minor, and then there is the major release. So for the major release, it is the first number that changes. And this is when there is something really, really major that is changing. So you can just reset the whole thing back to 2.0.0. And again, this is dependent on teams. There is no hard rule to this. As long as you and your team agrees to a style and you stick to it, it doesn't matter. Another team may say, okay, we're just going to change the major, and then we maintain the 1.1. If we're coming from 1.1.7 and we change a whole major thing in the software, a team may say, we go with this style. Or another team would just say, you know what, we're just going to reset the whole thing and we'll start all over again from release 2, right? And this is when there is a major release. And if you notice, I don't know if any one of you guys have GT bank account. So I use GT, and I noticed that now they have a completely new UI, you know, completely different from how it used to be. That's a major release, right? And whatever version they were on before, that would have cost them to implement the version, you know, to a major release. So this is something you will get to see a lot of the time as you go along. All right, so let's now talk about the problems that this experience has caused for companies for a very long time before DevOps was introduced. And DevOps is relatively new. I mean, it's I think it started, the whole conversation around DevOps started in 2009 by some guys in Germany. And since then up to now, it has gained a huge attention, huge momentum over the years. And in the world of IT, this is still very, very new. A lot of things are still evolving. And yeah, so now let's talk about the problems. First of all, you know, all these releases can take a long time. You know, releasing a patch release, going through all this process, it can take a long time. But, customers are usually impatient. Imagine it takes a company months to release a new feature. That can be very, 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 very disturbing, especially if your competitors are able to release much more faster. And now you're beginning to see the whole use of the word fast and high quality. So DevOps is here to solve this problem of making sure that we're able to release new applications, new versions, whether it's a patch, whether it's a minor, whether it's a major, it has to happen really, really fast. And then all this process that you see right here used to be manual. Everything is manual. The application is coded manually, the application is released manually, the testing is done manually, the whole infrastructure, setting up the servers, the database, all of that is done manually. And it adds to the whole slow process thing. When things are done manually, it's prone to human error. It is prone to a lot of issues that can happen. You can miss a step. Because what happens is, because it's manual, engineers would have to write the technical steps to do something. And then if you hire a new engineer, that engineer will have to take that documentation. If they want to build a new server, they will have to go through some documentations and do everything manually. Okay, that ultimately causes the eventual code to be full of bugs, right? It's not of high quality, because bugs is not only with the application, even the servers that have been set up. When things are missed, the application may not have code, but the infrastructure itself is not stable and not maintainable. At the end of the day, it all boils down to user experience. So if the customers are not having fantastic experience using your product, then it becomes, you have unhappy customers. And at the end of the day, a business can go out of business, a company can go out of business just because they have a whole lot of unhappy customers. All right. So let's now go through, some of the roadblocks that companies face when they go through the whole release cycle. Okay. So first of all, miscommunication and lack of comms between developers and operations. This is now going to start transitioning into some of the things that employers or potential recruiters will want you to talk about when you talk about DevOps. They usually talk about philosophies, practices, and tools. Okay, so these practices, we have to take it from how things used to be before DevOps. So before DevOps, every team worked in silos. Developers, they just work in their own world. They develop the application, not caring about the operations guys. Okay, they don't care about the operations guys. They just want to do what works for them. Now, operations guys, on the other hand, they have their own concerns. They want to make sure that they run an application that will not cost them their system to start throwing alarms in the middle of the night. Okay, it is possible that if a developer wants to develop a feature and they use some libraries that exist and they just import it into their code, it's possible that the system that the operations guys have put together does not work well with that library. So you can imagine if they're both working in silos, developers are doing their own stuff, operations are doing their own stuff. And at the end of the day, when it's time to deploy the application, then things don't work well. On the developer's laptop, when he was developing his thing, it was working very well at that time. But by the time it goes to the production servers, it doesn't work well. So you can see now that this traditional approach had some hidden problems that just had a bad impact on the company. At the end of the day, developers get paid, operations guys get paid. They all get paid their salary. Who bears the brunt? It's the business, right? So this lack of communication between them, it causes a lot of problems. Developers don't know about the servers, so they can't run the app. Operations guys don't know about how the app works. So everybody just work in their own world. Developers write code and never think about where it will run. They only think about, oh, it's working on my laptop, and that's the end of it. Now, operators take the code without caring much about how the application dependencies work or what exactly it needs to run. So these dependencies may need some other dependencies to exist on the server. So for those of you who have been doing some of the projects 1, 2, 3, you'll notice that you have to run npm to install some dependencies and do some things. These are the kind of things that the operators do. So they ensure that those dependencies exist before the application can run, okay? Now, if the operators do not have that information, they don't know what dependencies they need to install. And that causes a lot of problems. Developers will just say, okay, sysadmin, here is our code, please deploy it and make it available. And then they deploy it and it's just not working, just because they don't know what's going on. They're not part of the process of making that software product available, okay? And then there's no properly documented guide on how to deploy the application. And then the operators, eventually, they reject the code when it doesn't run properly. Then developers go back to develop to accommodate system requirements. So like I said, if the systems have certain requirements based on the software they've written, after months of development, then they give it to the operators, and then the operators run it, it doesn't work, they give it back to the developers, and then they go back, spend another month to fix that, and they keep going back and forth. And at the end of the day, the whole process is just slow. So that's a huge problem that companies face when it comes to IT and software releases. Then number 2 here says, usually there will be a produced documentation on release steps, checklists on what must be done to achieve successful release. There is no automated process. So I've mentioned this before, that everything is manual. They eventually produce some steps and documentation on how the application should run and everything, which is definitely prone to error. Release takes much more longer due to communication. We'll talk about that. And then there's conflict of interest. Devs just want to keep on developing new features. Operators just want to ensure that their systems are maintainable and running all the time. And because of that, there's conflict of interest, and they keep pushing back and forth between each other just because everyone is working in their own world. Okay. Now, the communication problems between operations and the security team is another thing. So we've talked about communication problem between developers and the operations, but even within the operations, there is still that miscommunication going on, between sysadmin and DBAs, between DBAs and security team, because there's also, usually teams dedicated to security. And still the same problem occurs, because at the end of the day, the security team have implemented firewalls that they are not aware that the application needs to run in a certain port. So they deploy the application, it's not working. Why is it not working? Because a port is not open. And that's because there's communication gap between the whole thing. And at the end of the day, this whole thing comes back to the same thing, which is slow process. Everything becomes slow. Days go by, months go by, and users are not able to use the application. Then another team for testing. So end-to-end testing problems, which is done by a different team. So another team is involved with the end-to-end testing. Again, communication problems. And all the entire steps to release is done manually, slow, prone to human errors, preparing the servers, deploying the application configuration. So you can see that of all the things that is mentioned here, it all comes down to, slowness and eventually having a product that is not of high quality. Now, this statement right here is quite important. So this is why in some companies, people who have spent years at the organization seem to know a lot more than others. Okay, this is another huge problem. And transferring that knowledge is just too difficult because some documentations are just not easy to comprehend. So you see some long list of documentation. Oh, to provision a server, you have to do this, you have to do that, you have to configure this, you have to do that. It's all written in some Word documents that, even updating that document is usually a problem. You have many versions of that documentation, and sometimes it might be the old version that falls into the hand of a new user that joins the company, and he handles that document, implements the server, and then at the end of the day, it's not up to the standard because that's not the updated document that's supposed to be used. Okay, so even some documents are even lost in the process, and some never existed other than in the head of the engineer. Sometimes the long-standing engineer just knows the environment just too well that he doesn't even need any documentation to do things. And when things change, he just goes ahead, implements it, bang, 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 everything is working perfect. And that knowledge gets lost completely by the time he leaves the company. And, they start from scratch again. And it slows down the process again. And then the new engineers will have to discover why things are not working, troubleshoot, spend days and months trying to figure out things that the last engineer just knew out of the box. So when something terrible happens to the infrastructure running the software, it is really hard to bring back the servers to the exact state it was before it got destroyed. So this is another point where let's assume that everything is running fine in production, okay? And usually the systems back in the days, this was before the era of the cloud. Companies would have to plan the entire infrastructure. They'll have to buy physical servers, buy racks, network switches, build data centers, spend months planning this and building their whole infrastructure. And at the end of the day, something can happen, the whole infrastructure can get destroyed. It could be act of God. It could be, maybe fire or whatever. If that happens, all the software configuration, all the infrastructure configuration, everything just goes with it like that. It will take an organization a long time to recover from that. And that's why companies usually implement disaster recovery solutions, high availability solutions, where they have a data center in one part of the country, they have another data center in another part of the country, so that if anything happens to the first data center, they can easily switch to the other one so that business can continue to run while they are now working on the one that got destroyed and trying to bring it back to life. Now, DevOps is solving these problems in amazing ways. I mean, you can imagine the power of having a whole infrastructure destroy, and in a matter of 5 minutes, you're back to life. That is amazing. Like, you're back to life with the exact configuration that you had before everything went down. Just because everything is now automated, you have scripts ready to go that does things, and a click of a button, things are just working perfectly. Okay. Now you will begin to, understand why companies are willing to pay huge amounts of money to pay people with this kind of skills, right? If you work with companies in the US, they pay as huge as $150,000 a year for DevOps engineers. Some even earn much more than that. I have a friend that works with Apple that earns $450,000 a year as a DevOps engineer. $450,000 a year. Why? Because first of all, it is not easy to hone these skills, okay? And eventually, when you have the skills, it becomes something that lives with you. It's just, companies understand that you can't just hire someone today and say you want to train them to become DevOps engineers, and in 3 months, they're already doing the work. It doesn't work that way. It takes them a long time to hone the skills. And at the end of the day, it's usually a huge benefit to the company because they can get things done quickly. They can release software really quickly and having high quality software. And we'll go through how that works now. So that's going to be the next part we're going to start talking about. So any questions so far before I proceed? No questions. That's good. I hope you're enjoying it. Okay.
Yeah.
Sounds like we have someone.
Yeah, I know I talk too much. Okay, so
no, you don't. It's fine.
So yeah, so far so good. I've actually been following, right? I mean, I've been documenting some and taking screenshots. But my mind has been somewhere, I don't know, right? So someone raised an issue, and I think I happened to also fall in that categories. Like there were some of us that joined late. I joined on Thursday, although I have covered one or two topics. So, but I don't know what is like so by now, which project or which course should we actually be on before we can actually, be good, like on the same level or something?
You mean to be on this live sessions, right?
Yes, like now, like I just want to know if you're at the same level or something, because I don't know if you're going to start practical or something.
So I'm not doing any practical today. Even tomorrow, we're going to do a bit of practical, but we will gradually begin to go into things practically, okay? We'll take it a step at a time. But if you can, watch the Linux videos, okay? And get yourself to at least project 5, you will be good to carry on with this, okay? So even if next weekend comes and you're still not quite there yet, you can spend the following week as well. Just get yourself to like project 5 at least. Watch all the Linux videos, try to do a few practice here and there. If you can do that within now and the next 2 weeks, then you can carry on with us. Okay, because the next 2 weeks is going to be around Linux and just practicing and trying different application deployments. And we won't go deep into automations and things like that yet, at least for the first 2 weeks. Okay, I hope that helps.
Yeah, sure.
Okay, good. All right.
Hello.
Yes?
Yeah.
Yeah, I think you made mention of waterfall methodology, and I don't know whether you made mention of Agile. So I don't know what the similarity with Agile and DevOps. Is it the same?
That's what I want to ask. That's what's on my mind, honestly.
Okay, good. So I actually wrote it down somewhere. I may have missed that, about Agile, but it's still a good thing because now we're going to start talking about how DevOps has now come to the rescue, and there's no way I won't talk about Agile. And now that you raised the question, I can just answer it straight away. So Agile has a number of different project management frameworks within it, okay, that works very well with DevOps. Now, if you compare it with what's called Waterfall, remember I said that Waterfall is where they just start the projects, do everything all the way to the end. It's like a big bang development, and then throw it at the users, okay? Whereas in the world of DevOps, because software can be released much faster, you don't have to wait to the end of 6 months before you release software to users, okay? What happens is the software can now be broken down into very, very minimal viable products. Minimal viable products, meaning that something enough for users to start using. And if that's possible within 2 weeks, that means people can start using that software in the next 2 weeks. But because there is now this possibility to release software very fast and high quality code, that means every day we can start releasing new features. So there's a software now available in 2 weeks. Okay, 2 weeks, day one, we can do a release. Day two, another release. And every day there can be a release. As a matter of fact, some companies even do multiple releases in the same day. So that means that these software products will eventually become mature over time. And because Agile is a software project management, idea that encourages incremental releases, it works well with DevOps. So when a company decides that they want to start doing DevOps, Waterfall just doesn't fit into that model at all. Then they have to start thinking about, okay, how do we then introduce a project management concept that works well with DevOps? And in Agile, I don't know if they call them methodologies or framework. I keep mixing them up together, but for whatever it is, because we are not project managers, we are DevOps engineers, right? But whatever they call it, there is usually two of them that works well with DevOps, which is Scrum and Kanban. Okay, so with Scrum, they have this concept of sprint, and a sprint is just in terms of days or weeks that the team decides that is going to be a period where we can release a software. So usually a sprint in most companies is 2 weeks. So if they have 2 weeks of sprint, that means between now and the next 2 weeks, this is what we're going to develop. And at the end of that sprint, they can do a release. And then another 2 weeks, they start a new sprint, and then they do a release. So that is a project management methodology that works well with what DevOps is meant for. Okay?
Framework.
It's framework, right? Thank you for that.
Yeah. Mm-hmm.
So, but Waterfall just doesn't have any idea like that. Waterfall just doesn't work that way. You just have to develop the whole thing right from the start and the end. But with the framework of Agile, in this case, Scrum, it already has different ceremonies, they have different ideologies, they have different things. So I've mentioned about sprint. They also have this concept of stand-up. And that's the same concept that we have introduced in our Slack channel. You can see some of you are part of the stand-up channel, whereby you just talk about what you've done for that day. Every day you give stand-up of your updates, right? In the world of Agile, Scrum, that's another thing they do, which is every day you talk about your progress. So because DevOps is about fast software release, that means we're making progress on a daily basis, right? And the only reason why we can do that is just because now we're thinking in terms of automation. In the world of Waterfall, everything is manual. In the world of DevOps, the moment there is a process that gets repeated 2, 3, 4 times, the next thing you're thinking about is how do we automate this process? So every process is automated. And because it's automated, you can just click a button, and without much human intervention, you can just sit back and see the whole thing flow through. I hope that makes sense to you now. Right.
Please, can I ask a question, please?
Yes, go ahead.
At what point in Agile methodology does DevOps come in? At what point?
So they work together. The moment you start implementing DevOps in your team, immediately you're introducing Agile. And what framework of Agile you want to use is up to the team. So you can decide you want to go Scrum, or you decide you want to go Kanban. So Kanban is a little different from Scrum in the sense that they don't have the concept of sprints. So they just have things in the backlog and they just keep taking the tickets and keep implementing the features and whatever they need to do and just keep pushing it down the funnel. All right, everything keeps going. But with Scrum, you decide on all the things you want to do for the next 2 weeks of sprint, and you focus only on that. And you do that. And after the 2 weeks period, you do your release, you carry on, you go back to the backlog, you pick a new set of tickets based on priority. You prioritize whatever is most important to the business, and then you develop that, and then you keep going. So from the day one of adopting DevOps, you want to make sure that you adopt a framework that works with it. So it's not like, oh, we're doing DevOps and Waterfall, and then somewhere down the line, we begin to do Agile. No, it doesn't work that way, right? So, okay, let's do it this way. So let's assume that companies use Waterfall and it takes them months and everything, all the problems that we talked about, it causes all of that. And then they want to start using DevOps. What's going to happen is they would have to, first of all, begin to change their ideology of how things should work, okay? It now means that the developers and operations guys do not work in isolation anymore. They come together and they start working together, because this is part of the things that DevOps now encourage. Everyone now works together. Everyone work with the same code base. The operations guys that never used to write code before, they now begin to write some code because they're now dev and ops, okay? The developers who never knew anything about infrastructure now begins to understand about networks, understand about databases and how things connect together and all that. And they all work together to build this pipeline that makes releases very easy, right? So the moment they decide they want to go that route, from day one of doing that, they will change the approach from Waterfall to Agile. And then they decide, okay, are we doing Scrum or we're doing Kanban? Once they make up this decision, then they begin to hire people that will help them to achieve that. Then they hire a Scrum Master. A Scrum Master is that person that understands the whole framework of Agile and Scrum and helps the team to work together to achieve the whole, fast release, DevOps cycle, pipeline, and all that. So the whole thinking changes completely, and everyone begins to do things the new way. Okay?
Thank you.
All right. Okay, so I just noticed one typo. Let me just quickly fix that. All right. So now we need to talk about, DevOps to the rescue, and take notes here. It says, quickly deliver high quality code by removing all the blockers that causes slow down to the release process. So every time there is a release, back in the days before DevOps, where developers now give the code to the operations, and because there hasn't been communication between them, the operations sends back the code, and all the things that causes the release process to be slow, DevOps steps in and begins to fix that. Okay, so first of all, everything is fast. So new patch releases get to the users in minutes. Major releases can get to the users in hours or just a few days. Okay. Now, improved communication between developers and operators. So now in the world of DevOps, everybody is working together. Okay. Now there is automated process. Every step of the cycle is automated. We talk about development, we talk about testing, even testing is now automated. And that's why nowadays there are new jobs for testers. Previously, when companies hire testers to test code, they hire manual testers. These are testers that Once the software is ready, they just go into the browser. If it's a mobile app, they go into the mobile app, they just test everything manually, right? But now you can write code to do all those tests. Literally, the code will run, and the same things that manual testers will do, which is to click on buttons and fill in forms, these processes will do all of that automatically. It will fill the form, it will submit, it will do all of that. So even though automated testing is not the job of DevOps engineers, it is still part of the whole DevOps lifecycle, because previously, the people behind the whole move into DevOps, they usually don't like the term DevOps engineer, because there is nothing like DevOps engineer. It's not a role. It's actually a way of doing things. So if they say DevOps and automated testing is part of it, ideally, it means that whoever is involved in the whole DevOps thing is making sure that we have automated everything, which includes testing. But nowadays, there is now DevOps engineers. I mean, the industry just couldn't help it but to call people doing it DevOps engineers. Even though traditionally, when DevOps started, the whole talk about DevOps is not really about the role itself. It's more about the culture, the new way of releasing software. But now that there are DevOps engineers, automated testing is really not part of the job description of a DevOps engineer. So bear that in mind. So as part of the whole process that DevOps engineers put in place, DevOps engineers just make sure that part of that pipeline is automated testing. Now, it is another set of people that will write those automated test scripts, but the DevOps engineer will just make sure that those test scripts are part of the pipeline. And I'll show you a typical example of a pipeline today so that everything we're talking about is still theory, but at least have an idea of what a pipeline looks like, right? Then we have quality code, which means that with automation comes a lot of great benefits. There's something we call quality gate. So as part of the pipeline as well, things are tested, and there is also what we call quality gate. So that means that when the pipeline is running and there is a stage in the pipeline that does not satisfy the requirement for a quality code, that pipeline fails. And that means that the code does not make it to production. It fails, and the relevant people working on the part that failed gets notified. And then they go back and look at it and say, okay, this is why it failed. We need to then make sure it passes the quality check. And then they trigger the pipeline again. Once it passes, then it goes through and eventually it gets to the users and everybody's happy. So you see, part of the automation is making sure that not only are we able to release software, but we're also able to release quality software. Okay, now let's talk a little bit about testing. So there's different kind of testing. Sorry, are you saying something? Is someone trying to ask a question?
Yes, I have a question. Can you hear me well?
Yes, I can hear you.
So my question to you becomes, when you said that about the automation of testing, is that something the DevOps engineer will be required to write himself, or is that something the automated testers would do? Because you said the code knows that this code, the system would know that there's a bug in this code. So how are you going to know? How is the system supposed to know that this is based? I mean, I understand that you have the requirements and you have to set up test cases and things of that nature, but how would you as an engineer set that up in the system to?
That's a good question. So now that was actually going to lead us to talking about a different kind of testing, so that you then understand where DevOps fits into the whole picture and who does what and what. First of all, like I mentioned before, you as a DevOps engineer, you don't write any test cases. There are automated testers who write those test cases, and they give those test scripts to DevOps engineers that put it as part of the pipeline. Okay. And like I said, I'll show you an example of what a pipeline looks like, so you begin to appreciate how things get placed into places. And one thing that DevOps engineers then do is to configure the pipeline such that if these test scripts fail, because the test script will be testing certain things, and if those tests do not pass, the DevOps engineer makes sure that the pipeline breaks and it doesn't move on to the next stage. And then it notifies the people in charge, and everyone goes back to the drawing board and they fix whatever needs to be fixed. Okay. Now, there are some tests that it is the developers that write those tests. Some other kind of tests, it is the testers that write the test. And that's where the first test comes in. So there's unit testing, which is being written as part of the code that the developers write when they're developing the software. So this is testing every little function and methods and classes and, the different things that they're writing in their own code. As a DevOps engineer, you have no business with that. You just make sure that when the pipeline is running, it's able to run the unit testing written by developers. And if those tests fail, then the pipeline fails, okay? So that's one part of testing. And each test tries to satisfy different requirements. What I mean by that is unit testing is basically testing the code itself, making sure that if the function that the developer has written is meant to calculate 2 plus 2, and 2 plus 2 must produce 4, right? When the unit test runs, it tries to calculate 2 plus 2, and if it produces 5, then it is wrong. And at that point, the pipeline fails because that code is not doing what it's meant to be doing, okay? And that's all about unit testing. It only tests specific units in the software code, and that's it. It doesn't do anything more than that. Now, there is another kind of testing, which is called integration testing. At this point, all it's trying to do is test the code with other systems. And that's why it's called integration. When developers are working on a certain feature, they're basically working on the feature, for example, developing login functionality, making sure that a user is able to log in with a user and password. End of story. But at that point, the testing there, the unit testing there is not testing whether, imagine if, I'm sure you must have used websites whereby you can log in using Gmail, or you can log in using your Facebook account, or you can log in using your LinkedIn account. You're basically not using your username and password. You just click on the logo of another website and it uses the login credentials that you use in Facebook to log you into a different application. I'm sure you must have seen that. That is a typical example of integration because you are now working with another system. You're trying to connect with another system. So these are the kind of tests that happens at the integration stage. You're no longer testing your own software, you're testing how your software works with other systems. That's the part where when developers are doing their own development on the laptop and there is need to connect with the database they use at that point is probably installed on their laptop and it just works because it's installed there. Now, when you go to other environments, the proper infrastructure, the database is probably sitting in another data center. Now you need to test the connectivity between your application and that database. That is another example of an integration test, making sure that every bit of integration that needs to happen works perfectly. No errors, nothing whatsoever, okay? Then another kind of test is performance testing. And all this testing have used test cases that has to be written by the testers. this time is trying to test the performance of the application. Can this application handle a load of 100 users? How does it behave when it now starts seeing 100,000 users? How about 1 million users? How does the system behave? That's another kind of testing. At what point does the system break and give up completely? You know, they put up a lot of load on the system, and it could be that the point we reach 100 million users, we cannot scale beyond that. Now we know, right? The testing will tell us that, and now we have that information. So what that means is, if the business becomes successful and now we're beginning to get close to 100 million users, active users, we know that we need to probably re-architect our infrastructure, re-architect the application, or do whatever, but we know that this is our threshold. Some applications are designed never to reach that threshold. Imagine if the application is just developed for internal use by the organization. They're probably never, ever, ever going to have 100 million staff working in the organization. So there is no need to re-architect that kind of application, right? So you see where all this is not getting to. So you test for different things, you know, so that you can make different decisions. So now, as part of the pipeline, if there are automated testing for performance, and you are testing that the code should be able to handle 1 million users, and by the time you throw some load and you've thrown maybe 100,000 users and already the application is struggling, then that test will fail. And that means it is not fit for production yet, because it doesn't even have the capacity to handle the amount of users that this software is supposed to serve, right? Then we have the penetration testing. This is where we test for potential attack. So what kind of attack are we expecting? There is SQL injection, there is cross-site scripting, there is different kind of attack that can happen. People maliciously acting like a valid user, trying different application, different passwords, you know, different kind of tests that can happen from a penetration perspective. There are test cases that will be written for that, and you can test that. Then end-to-end testing is basically testing the whole thing, making sure that the front end is working perfectly, the back end is working perfectly, the APIs are working perfectly, you know, all those kind of things. You know, so it is the job of a tester to write all these test cases and basically give it to the DevOps engineer. And DevOps engineer just puts it in the pipeline and sets up the pipeline. And every time there's a new release, triggers the pipeline. It goes through all the different build, test, release, and then if anything fails or falls short, it gets rolled back and it never makes it to the production system. Okay, so we didn't have all of these before DevOps. As a matter of fact, these tests actually existed then, but they were all more of manual approaches. Now we have a pipeline that can get to run, and everything just happens automatically without you having to do anything. When a new software project starts and a new DevOps engineer is being introduced and he's been tasked to set up all these things, initially it might take quite a while to set the whole thing up. But the beauty of it all is the moment these things are set up, it just continues working. There's no need to try to remember some documentation, because as a matter of fact, your documentation is actually the code itself. Everything you want to do is part of the code. And if somebody is trying to understand how things work, they don't need to start looking for some document here and there. They just look through the code and they understand how the whole system should work. Even the pipeline is part of the code, right? Okay. Can I move on?
So I have a question that kind of ties into the whole, the beginning of DevOps, you know, where we have Dev and Ops come together, that intersection.
Yeah.
So, and I hope I'm not jumping the gun here. So, you know, when we're talking to potential recruiters or hiring managers, there's this notion that you have to either be coming from you used to be a developer, or you were some type of systems administrator.
Admin,
yeah, like, you know, you're like a Linux guru of some sort.
yeah.
One part of it is, how do we navigate around that, where we really, you know, didn't grow up in that either of those lines, but here we are, we're DevOps engineers now.
Yeah. I mean, it's a tricky one. All right, it's a very tricky one there. And what I'm gonna say to that, 1 second. So to respond to that question, I've had to say the answers in certain ways off camera, but just to reiterate, because this is now continuing the recording, you just have to be able to convince the recruiters that you have the experience in either of the world, either dev or ops, and put up some profile that presents that. Now, that's why doing this project-based learning, you have to also start putting your profile together. Profile that I mean is your GitHub repository of the projects that you've done. So all these projects are for a reason, documenting them is for a reason, writing your empty files, talking about what you're doing, what you're implementing. They just have to have the confidence that you have worked with Linux, you work with Jenkins, you work with Terraform, AWS, you know, just convince them. And, you know, hopefully you find someone who would take you for your word and give you an opportunity for an interview. And that's when you then use that opportunity to shine. If you're a good talker and you have implemented projects, those projects will keep coming back to your mind, and then you will have something to talk about. Or if you've just watched videos, you haven't implemented projects, you just know you know certain things and they won't be coming back at you as such, okay? When you implement the projects, it kind of sticks to you. And especially when you finish a project and then you try to attempt that same project again, because reiteration and continuous practice is all you need, you know, for this, okay? All right. So I hope that helps. So
Please, can I ask a question?
Yes.
Sorry. Please, you said software testers write test cases and test software.
Yes.
Wow. They give their test script to DevOps engineer to you know, for the pipeline.
Yes.
Please, I don't understand how it works around that side.
You will understand. Just hang on to your gilly that I'm seeing in your picture right now. So you will understand shortly, because I'm going to show you an example of a pipeline and you will see where that fits into, okay? And that's why it's very important that we have this session so that you understand the big picture, first of all, and then we'll now go back to implementing things. And then at least now you know where we are heading. Okay, and the good thing that you guys are going to be the second batch of this masterclass is that we made some mistakes from the first batch that we're trying to correct here. You know, the first batch, we didn't really give them this full picture initially. We just went into doing technical stuff and a lot of people struggle. And then in the end, when we did this session, it then made sense, but unfortunately not everyone, you know, stayed to the end. So the good thing with you guys is you're having the big picture right from the start, and then you can easily run with that and it will make more sense to you as we go along, okay? All right, so now more secured application / infrastructure, since DevOps also strongly considers security in the process. And you may have seen things like DevSecOps from time to time. So, you know, DevOps is dev and ops, and then putting sec in the middle is basically saying development, security, and operations. So part of what you'll be doing as a DevOps engineer is not only to ensure this fast and quality release of software, but also to integrate security as part of it. And some of the security, you've actually been doing it. For those who've been working on project 1, 2, 3, you've configured security groups in AWS, right? That's part of DevSecOps. Now, a very basic one at that, but There is a whole lot of much more advanced concepts to DevSecOps, which you will get to see as we go along. But at least you understand that automating all the processes that we're talking about is also automating security as part of it, okay, which is a big benefit that DevOps also brings. Now, because both apps and infrastructure is automated, it is also easy to replicate the entire stack to the exact state it was before it was destroyed. So I've mentioned this before, and the software can be back in business in a matter of minutes. You don't have to remember any documentations or follow any checklists or whatever. Simply execute DevOps code solves the problem. So if you lose your infrastructure, you lose your application, you lose your servers, you lose everything, you can just run one Terraform code and it brings everything back. You move on to maybe the next code, you run another Docker orchestration related code, and everything just comes back to exactly how it was before it went away, right? Ultimately, you have a much more happier customers, and you have much more quicker feedback for further improvements. So imagine that.
Can't see your screen.
Oh, you can't see. Oh, I'm so sorry. Okay, I stopped sharing previously. Right. Okay. Can you see my screen now?
Yes. Yes.
All right. Okay. Thanks for spotting that out. So now we have much more quicker, happier customers, and imagine now that we are following DevOps practices right from the start of an idea to software development, and in 2 weeks, there is a product readily available for users to be using. Maybe not mature, but it is something. And then we can start developing on top of that. Now that in 2 weeks, customers are able to start experiencing your product, what that means is you can quickly start getting feedback, and rather than waiting till the end of 6 months or 12 months before you can complete a software development, where you now have some feedback, then that also means that you have to go and redevelop some things, and some things that you have developed probably is not going to be used by users. You get that kind of feedback quickly early on. After 2 weeks, you start collecting feedbacks, and some of the features that matter most, you start focusing on them more. Remember, with Scrum, you can have 2 weeks of sprint. Now, in the first 2 weeks that you release your software, you're starting to get feedback. You're planning the next sprint for 2 weeks. The feedback can help you prioritize the features to release next, so that you release the most important features to your customers, and you don't release the one that you feel is important, because you have to be able to detach yourself from what the customers actually want. What you want is not what the customers want. The customers are king, so they have to be able to be the driver here. So if you're assuming for the customers, then the business is making a lot of mistakes. So it's also very important for the customers, for the business to release the product quickly and get feedback. And that is exactly how even our business, the Diary.io program, has actually operated since the time it was launched. This program was launched when the pandemic started, and it was just a landing page. There was no dashboard, there was nothing. It was just a landing page that just talked about the fact that you can do project-based learning and learn things, right? And that landing page was ready in just 2 days. So we had the landing page, just put it online and started doing some adverts here and there on Facebook, Instagram. And then we started getting some customers, and people started paying for the program. And then we started getting feedback quickly. Based on the feedback that we've been getting is where we are today. When we started, we weren't doing any live sessions at all. It was just the documentations, the project, but we quickly realized that people were struggling understanding, some of the concept because it's completely new to them. They just needed someone to talk to. Then we introduced the support channels. We introduced the live sessions. We introduced a number of things. And then feedback kept coming back. And eventually we introduced the masterclass. And that's how we keep on doing. We improve the website and moved away from the landing page. Now we have a dashboard and we continue to evolve over time. And that's a typical example of how businesses now run with DevOps as part of their approach to releasing software to people. And it's amazing, because first of all, it helps companies to not waste money on things that don't matter, okay? You can focus on things that matter. You can release much more quickly, and it's just the best work for both parties. The customers are happy because they're getting what they want. The business is happy because also you can see progress, from time to time. All right. So the last part is to actually talk about, these cultural philosophies and practices and tools and, what tools and, how the whole thing works. And this is where we now gradually start getting into the technical side of things. Okay. So devs and ops should work together and communicate much more. So we've talked about that. Now we know that. DevOps is not a specific set of tools or practices because each organization is different. Hence, they all implement DevOps differently as long as it achieves the goal of fast and high quality code release. So what this means is we're going to talk about the different tools very soon. So, there are categories and tools and all that. So I've made a list of a few things. We'll talk about them shortly. But it doesn't mean that every organization must use all these tools. So DevOps is implemented differently, in different organizations. And that's why when you see DevOps job descriptions, do not get overwhelmed when you see some technologies that you are not familiar with or that you're not comfortable with, okay? Because most of these technologies do the same thing. It's just that company A is using a type of tool that company B is not using, but company B is using another tool that does literally the same thing that the tool at company A is using. If you're able to convince a recruiter that, look, you're asking for products or tool X, but I've actually worked on tool Y while I was with this company. But I do understand that tool X does the same thing that tool Y does. While I was using tool Y, this is what I've been able to use it to do. This is what it does. This is how I use it. This is this and that. Companies are happy to hire you because even though you haven't used the exact tool that they're using, you have the fundamental knowledge about that tool. It's just a matter of joining the company and just evaluating that tool and spend maybe 1 or 2 weeks with it and boom, you're ready to go, right? So do not get overwhelmed just because you see some job descriptions and you're not familiar with some of the names that you see. Just research those names. You will find out that while you're doing this project-based learning, you have actually used those tools. It may just not be exactly what they're asking for, but it will do the same thing, okay? So bear that in mind. So basically, why I'm saying this is because DevOps is actually implemented differently across different organizations. And we all know that. I don't know all the tools that I've written down here. I don't know all of it, okay? But what you want to do is you want to focus your energy on the ones that are mostly used because some of them are heavily used, some are not heavily used. Don't spend your time learning the ones that are not heavily used because when you start looking for work and you see a job description and you see maybe 10 jobs, you want to be able to be in a position where 8 out of those 10 jobs are using the tools that you know, right? So that's very important. And that's part of the things that this program is going to help you structure your learning to focus on the tools that matter the most, okay? Now, so this last part is exactly what I've just talked about. Now, let's talk about the different tools. So these tools are based on categorization. Okay, so I have identified 9 categories. You just want to make sure that at least you know one tool within those categories. So let's start with planning because again, it all comes from idea to requirement gathering to software development and all the way to production and monitoring and all that. Yeah. So when it comes to planning and a collaboration, remember now no team is working in isolation. Everyone is working together, developers and operations. So there has to be a tool that brings them together, right? So there is Jira, there is Azure DevOps, there is Monday.com. There's quite a number of different tools out there. The most popular one is Jira, and you may also see it's called Atlassian. Okay. So it's the same company. I think the name of the company is Atlassian, but they have Jira. They have a number of different tools. And Jira is basically a tool where you can create tickets, put descriptions in there that talks about the task that needs to be done. Okay. So I can show you let me see if I can bring up a Jira. One second. Let me see if I can get something to show you so that I can show you some of those tools as we go along. Okay. All right. Okay, no, actually not. Let me see where I'm logged into. Okay, log out. Okay. So this is Jira, and this is one that we use at Dire.io. Let me just go into a different. Okay. So this is an example of a Jira dashboard where you have to do, you have in progress, you have done, and these are just tasks that people get to work on. So if I open this up, for example, let me find one that has some description. Okay, well, so this doesn't actually have a description, but this is an example of what a collaboration tool looks like. So you have the title. So here it says configure Terraform to deploy Nginx Ingress. It's basically saying what needs to be done. And then there will be a description here. Now, it depends on the size of the company. In some organizations, you have product owners. Some will be solutions architects, where they know what needs to be done and they will be the ones to write the description. Okay. And then they can put, there will be section where people can put comments, and this is all about collaboration. Someone from the dev team can write a comment here. Someone from the ops team can write a comment. Different people now begin to collaborate together. And this is an example of a collaboration tool right there. Okay. Now, there are a number of options. There's Azure DevOps. This is the Microsoft products. And, it doesn't matter, whichever one, they all work the same way. Have some title, have some description, you can put comments, and you can upload documents to whatever you want to do. Then there is source code management. And the most popular here is Git. There is also SVN, but there's quite a number of different options as well. Okay, there is, now there is other ones like, let me just write this, GitHub, GitLab, quite a number one. Now, there's difference between GitHub and Git. Okay, so don't get confused. There's Git and there is GitHub, GitLab, and those other ones. I will not go into the details of what these things do at the moment. Just know that a tool that helps developers to do source code management. What source code management means basically is, we want to release a version of the code. You need a management tool that can help you determine, are we on version 1.0? Are we on version 2.0? Are we on version this and that? And it allows different developers to work together on the same code base. You can imagine this application right here that has all this, code. This is an example of a code that does certain things, right? And a developer can be working on this part of the code and another developer working on this part of the code. And how do we all work together to the point where we don't overwrite each other's code? This is where a source code management tool comes to play, right? You just have to be able to know one of them very well. And the huge one is Git. GitLab and GitHub is just a front end to Git, really. Okay, so but you get to see all of that in action as we go along. Then there is continuous integration and delivery tool, right? So there's Jenkins, GitLab CI, Circle CI, GitHub Actions, Drone. There's quite a number of them. The biggest one, which is Jenkins, but things are a little bit changing gradually because now people are beginning to use GitHub Actions and GitLab CI, but it's okay if you just know one of them for now. The other ones are easy to use. Jenkins is actually the much more quite difficult one to use, okay? So, but we'll get to that because we're going to be heavy on using Jenkins on this program. Then there's the cloud. So you have AWS, Azure, GCP, DigitalOcean, Heroku, Alibaba Cloud, there's, a number of them. Our focus is on AWS on this program, and it's the biggest because they started the whole move to the cloud. So they started the whole cloud infrastructure thing, and other companies started following suit. Right? So AWS is Amazon Web Services, and some of you have been experiencing that in the course of your project. Then there is container and container orchestration. This is where you're going to spend a lot of time. And this is now becoming the standard in the whole DevOps world. If you don't know any other thing, you have to know this. But in reality, you can't know these unless you know a few other things like Linux. So to work with Docker, you have to understand how to work with Linux and all that. And then Kubernetes, which is the biggest one when it comes to container orchestration. So we'll get to use all of that. Then there's infrastructure as code. So the whole infrastructure we're talking about, the servers, the databases and all that, having them as code is another big deal in the world of DevOps. So there are tools that allows us to have all this to work. And the big one here is Terraform. There's CloudFormation by Amazon. There's ARM templates by Microsoft. But the biggest one is Terraform by HashiCorp. And you just want to be able to know how to use this. And the only reason is because this Terraform works with many of the cloud infrastructure tools. It works with AWS, it works with Azure, works with GCP, works with DigitalOcean, works with, literally all of them using what we call providers. But CloudFormation is specific to AWS. You can't use it with another cloud infrastructure tool. And ARM templates is by Microsoft, only works with Microsoft Azure. And that's the reason why, people prefer to use Terraform the more because it sort of works with all of them. So why would I want to learn a tool that is focused on one thing when I can learn a tool that companies love just because you can use it with any of the cloud providers? Then there is continuous monitoring and logging. So remember, after we have deployed the application, we have to continue to monitor it, right? There are tools that allow us to do that. So there is Prometheus, Grafana, the Elk Stack, which is Elasticsearch for logging. It now has a lot of monitoring part of it. There's Datadog, there's Splunk. There is so much more that I can't even fit the list in here. But we're going to touch base on a few of them in the course of the program. We're definitely going to use Prometheus, Grafana, a little bit of Elk, and that's it. The other ones, you can explore them on your own. You can watch some YouTube videos here and there and just get information. Now, configuration management is another one that used to be very big, but because containerization and orchestration is taking over, this is gradually losing its hold in the industry. But it's still relevant because some projects are not yet in containerization. In fact, some companies will hire you just because they are just about to move from configuration management here to orchestration. So you need to be able to understand these to some extent for you to work on such projects, right? So that's why it is still relevant. But I envisage in the next couple of years, this might gradually start phasing out. But here, Ansible being the biggest one here, you just want to make sure you know that. And that's part of the PBL that you'll be doing. And then package management. So package management, which means how do you package the application and deploy it onto the servers? So there is Helm, which is also very big in this space because of the whole containerization and Docker and all that going on right now. So Helm is big and we're going to be doing that. But then there is other package management tools like Maven, NPM, Yum, apt, and we'll get to work with, all of these things. So as you can see, there is quite a lot of work that still needs to be done, but we will take them one step at a time. Don't forget, you're going to have to watch videos, and then we'll come here to implement those things. So when I ask you to watch videos during the week, please make sure you do that. Try to watch those videos. Try to have basic understanding so that when we come to class, it becomes easy for you to follow along. Okay? Now, before I go to the last part, because I am a little conscious of time now that we spent a little over 2 hours, so that we can end the session, I just want to quickly show you what a typical pipeline looks like, okay? Because I know a lot of you are yearning for that already. So let me maximize this. And I'm going to show you, first of all, what the visual pipeline looks like. And then we'll just have a quick look at what it looks like in code. And then you begin to make some sense of it. First of all, we talked about source code management. So it all starts from source code management because developers have to build the application code. Let me bring that back. So here, as you can see, I showed you all this code previously, right? This code has to be built and packaged in such a way that it becomes easy to deploy onto servers. So that's usually the first stage in the pipeline. So this code, many people work on it. Say, for example, if, let's say, for example, if I run this command git branch, at the moment, you can see the asterisk right here. The only branch here is the main branch. Let me enlarge this a little bit. Okay. Okay, so git branch is a command I've just executed, and it just shows me there's a main branch, and the main branch is like where all the integrated features are. Now let's assume that as a developer, Dare is a developer, and I just want to work on a new feature. I just want to change this application code to start doing something new, right? I can do something like this, create a new branch, and I'll just say git branch, git branch, and then I name it feature. Let's say I want to create a login functionality. I could just say feature login. Okay, I hit enter, although it doesn't report anything, but if I now go back and say git branch, you can now see I have this feature login branch, which was not there before. But because the asterisk is on the main, it means that I am still inside the main branch. I need to be able to switch into this branch. So what I'm going to do is I'm just going to do git checkout, and then I copy this. And by the way, we're not doing anything technical today. If this is not clear to you, do not worry at all. We're still going to go deep into all of this, but this is just to kind of show you the big picture, okay? So as you can see now, it has switched into a branch called feature login. So that means I am not working on this branch. And what that means is I can start making changes to this code without affecting the main branch. It's just like having a version, a clone of the entire code. And then I download it and I have a copy of it, and then I can make my own changes to it. Now I can break the code in that branch, which will not affect other people because other people are working on this main branch. They have no idea about this feature login branch. So I can go into this and then I can begin to write my code and make changes and do stuff, okay? Now, the reason I had to show you that is because when we come back to the pipeline, let me go to the pipeline. Oh, why is it not showing? Okay, 1 second. Let me use my mouse. There we go. All right, so if I come to this pipeline and then I click on branches, okay, I'm actually using Jenkins. So Jenkins is a CI tool. You get to use Jenkins as well. Don't worry how this all came about, okay? Just know that right now we now have a Jenkins CI tool that can help us to build a pipeline. Now, if you notice, there is a pipeline here. It says feature, oops, let me go back. Sorry about that. It says feature some design. Now, this is an example similar to the one I showed you just now where I did feature login. So this is some design changes that maybe a developer tried to work on, right? Now, this branch can trigger a pipeline specific only to that developer. As you can see here, there's another one here that says Toba branch. That means the name of the developer is Toba, and he was trying to do some things, and in his own branch, he can actually have his own pipeline there. Now, if I go to this feature some design and I hit on play button right here, which is run, okay, you can see it started this pipeline and I can open it, okay. Now in this pipeline, things are not going to start working. As you can see, there is this, line now that shows that there's a pipeline, which means things happens in stages and steps. So right now it says queued, waiting for next available executor. So everything is automated. So an executor is basically a server that will take the instruction for this stage and execute it. Now, what's the first stage? Building the software. So you have to build the software, which is the code that the developer has written. And then the next stage is going to do some testing on it. You can see there's unit testing stage. Then there is a quality gate, which will check for some quality, and then it will deploy to an environment called the development environment. As you can see now all the checkboxes have happened and the whole thing has occurred. Now, what you're seeing is just a simulation of a pipeline, okay? There isn't really a particular thing that is doing behind the scenes. It's just simulating it just to show you the bigger picture. But you'll also see how it looks like in code shortly. So this is happening only in this branch where this developer has worked on. And it deploys to an environment called dev. What that means is an environment is basically a set of servers that the code gets deployed to. Back in the days before DevOps, the operations guys would take the software code, put it on servers, connect it to database and all that. This is also happening here, except that this environment, it is not open to the public. It is not open to the users. It is not the production environment. It's just a development environment. It's just an environment where you can then go and just test your code yourself and just see if the feature that the developer has written is working. So this dev environment is an environment that DevOps engineers will make available for developers, and developers can just trigger this pipeline, okay? Like I showed you just now, I clicked on play. This pipeline is something that DevOps engineers will put together, and developers can now begin to use it. They can just create their feature branch, and then they come here and then they just click on it and then see what happens, go to the environment, test their code. Now, if this developer is happy with this feature and is working as expected, what will happen is he then comes here, okay, and raises what we call a merge request, all right? So he will run some command and eventually he will do git push, okay? So there's an error here, which basically saying, okay, you can just copy this and push the code. See that? So what it means now is that there is now what we call the merge request, and it says here to create a merge request, visit this link. So he has given us a link. So let's copy this link right here and go to the browser so that you will see what it looks like. Let's do this here. And I've copied the link. I'll just paste this. And now it brings me here, and because there is no change, we didn't actually create it, but let me just create the merge request just for argument's sake. All right, so you can see changes here says 0 change, just because, we didn't actually make any change. But if there were code changes, this is where you will see it, okay? And once the Actually, let me make a little change so that, because that's when this is going to make a lot of sense to you. Let me just make a little change. Let me just put something different here. Location, and I'll just put it, let's say the developer has changed this to insert. And if I now clear the screen and do git status, you can see that there's a change here. And if I do git add -p, which is a command, actually it says no changes. Let me go here. Okay, so this is the change, right? So if I do git add -p, you can see here, it shows me that there's a potential change from location to insert, which we've just done. I say yes, and now I can say git, oh, actually, this is master. Okay, sorry for the confusion. So I haven't actually created a branch out of this because I was in a different repository previously. But let me just create the branch again. Git branch feature login change, give it a different name. Then git checkout login change. Okay, so now I've switched to this branch, and because I've made the change, I need to do another thing which is called git commit, change the login functionality. So we're just simulating, a change where a developer is making some changes, and now we're going to push. Okay, and now I'm going to copy this, paste it, and push. Okay, and now there is now a new branch. So let me go here. Okay, so you can see here, feature login change had recent pushes less than a minute ago. It says compare and pull request. So now I'm using GitHub here. The previous one was using GitLab. So the terminologies are different. In the world of GitLab, it's called merge request. In the world of GitHub, it's called pull request. Now, don't get confused with all these terminologies. You get used to them over time, But for now, we're creating a pull request in GitHub, which is similar to merge request that I mentioned previously, because I thought I was using GitLab. But anyway, now we have this pull request, and if you notice, file changes here shows that we're now changing this to that. Okay. Now, if I go back here, let me go into administration and just quickly go to and click on scan repository. So I'm going to scan this repository. And if I refresh this, I should be able to see that new branch. Okay, so as you can see, feature login change has shown up here. So this is the new change. And if I click on this, the pipeline is about to execute. So it's going to build the code, it's going to run unit tests, and it's going to deploy it to some environment. And then this functionality that I've just introduced, I can go into that environment and then test it. The environment may actually be a URL. So for example, let me show you an example of an environment. If you go to diary.io, this is the main website. This is our production environment. So that means this diary.io is running on some server. If I come here and I do host, if I run this command host and put this here, let me just remove all these HTTPS and all that and www. You can see host diary.io says diary.io has address 352.147.7178. This is the production server that our code is running on. Okay. And yeah, so basically, this is our production environment running on some server that has that IP address I've just shown you. But we do have other environments. We have a staging environment where if you go to staging-learning.io, you would see it's similar to the main website, but as you can see, it has a different kind of UI. You know, the box has gone to one side, and that's to show that there is a version of the code that was deployed to this environment that is not the quality that we intended. So this is an example of what is going on here. So as you can see, it says building the software, doing unit testing, there's a quality gate, and then it deploys the environment. Guess what? There are other stages that didn't get to run. Deployed to integration environment, it was skipped. Deployed to pre-production environment was skipped. Deployed to production was actually skipped because this is running from a branch not intended for production. This is still during development where developers and ops are working together. Ops have put up this pipeline and developers can push their code and everybody can see what's going on. Okay. Now, let's go back to the code here. We can see that the pipeline has run. What's going to happen is merge pull request. So that means we're now going to merge these to the master branch. But I'm not going to merge this because this is not what I intend. But let's assume that we're going to merge these and it goes into the master branch. What will happen is, if we go back to the master branch, so I'm going to check out back to master branch. Git check out master. So it says your branch is not up to the master. This, as you can see, that change has come back to location. So the change I made previously did not affect this master branch. So that means that this master branch is the stable branch, is the one that everybody else is working. It's probably the one that was deployed to some environment for proper testing. But the feature branch is the one that you've deployed as part of your development, deployed to some dev environment, okay? Now that we're back in the master branch, let's see what happens if the pipeline was to run from the master branch. So if I click on branches, there's a master branch here. Let's click on this master branch and see what happens. So building software, unit tests, quality gates, the same thing happens, but this time around, you would see that the behavior is going to be slightly different. So let's just wait for it. I'm getting a little bit cold here, so I'm just going to put on the heater while we wait for that. Right. Okay, so it's about to kick in. We're waiting for it to kick in. And sometimes, it might take a while for it to kick in because if other people are using the system, there are other jobs that are running, other pipelines running, it just waits for its time to get an executor and then it begins to run. So now it's picked up an executor. You can see it's done building the software, unit testing, quality gates. And once quality gate passes, it skips development environment and then it goes straight to integration environment. Okay. And that's because it is the way the pipeline code has been written. The pipeline code has some conditions that when it is a master branch, deploy to integration environment, do not deploy to production, because we don't want the master branch to be deployed to production straight away. We still want to do some integration testing, and ideally, there could even be more steps in between here, because once it deploys to integration environment, all those integration tests will still occur. So if this was not there previously, DevOps engineers can then take the test cases written by the testers and begin to put it in the middle of it. Now that you have an idea of what this looks like, now let's have a look at what the code looks like for the pipeline. Okay, so this is where this file comes in, Jenkins file, because it is the Jenkins file that handles the whole code. And it looks a little bit like Java code. So if we have some Java developers here, this will look more interesting to you because basically it's just, it's more like calling a function and then you open some curly braces and you put whatever you want to do in there and that's it. But don't worry too much about the syntax for now. It's very, very easy and there's tons of examples online that you can always use, copy, paste, use, and as long as you understand what you're doing. But let's just go from the start. Basically, what's going to happen is, let me remove all of this for a second. And the whole thing starts from having a pipeline. So you have a pipeline, you open a curly brace and close the curly brace, and everything you want to run in that pipeline will be in between these two braces. Okay, so I'm going to put that back. So now that we have that, the next thing is you now need to have, this keyword here that says agent any. You remember when this starts and it says waiting for an executor, right? That is what's going on here. So this is the part where it picks an executor, which is an agent. So any agent available, run on it. Then the next part is the different stages. So if you notice, there is stages and there's only one stages. If I take this now, you will notice that inside this pipeline, open and close braces, we have stages as well that has its own open and close. So all those stages will be inside these open and close braces. So all the stages that you see right here is basically inside of these, okay? So we have the pipeline and then we have stages, okay? So I'll put that back. So within stages, right, you then have stage. So let me remove all that so that you can see the first stage. So the first stage here, it has its title, more or less. So building the software. So if I go back here, you can see building the software. That's what you see right here, okay? And then you have steps. So what are the steps? So what we're doing for now is we're not really building any software. This is just simulating a pipeline for you. So all I'm just doing is just echoing the word or the statement building the software. That's all it's doing. But you just need to understand the flow. Stage, the first stage has this step and that's it, okay? Then you have multiple other stages. So this stage, done. And then this next stage, where's the next stage right here? This is another stage, unit testing. And everything you want to happen within unit testing, you put it there. So you see that part where I say that, the unit test people will give you the test script and all that. This is where you put it. So once you have the test scripts, you basically put it within this place and it runs whatever they have developed and that's it. Okay, so that when the pipeline gets executed, it then executes the test cases that they've written and it already has the conditions there to fail if it doesn't pass that test. So if there are penetration tests, there are integration tests, whatever kind of test, this is where you begin to put it. So you just create a new stage, give it a title, and then you use your shell knowledge, your Linux knowledge, because it's actually running on a Linux server, okay? It's running on some Linux environment that understands Linux. So that's why you see this SH here. This SH means shell. So it's running shell commands. So whatever you run on a shell is basically what you can put in here. I can literally copy this and put it on my shell terminal. This is my shell terminal. And I can execute the same command, echo this. And you see, it's just going to echo back exactly what I've typed in there. So this is what this SH is doing. So as you can see, this is what a typical pipeline looks like. You just have this file, you put all your pipeline in there, you connect it to your Jenkins, and Jenkins gives you this nice interface, and then you're able to click and all that. Okay, of course, there are things you need to know: how to set up Jenkins, how to connect your source code tool, Git, to it. All these things, how they all play together. It's a different conversation entirely, which we'll go through, in due course. Now, let's now see how it gets deployed to production. Because if you look at this right here, there are some of them that has other functions. Let me bring this down so you can see it. So look at where it's deploying to production. It has this function here that says when. So when building tag. So that means this stage would only run when this condition is true. Okay. And then we have some other commands here that says, timeout after 10 minutes. And then it's asking you deploy to production. If it's okay, deploy it. Now I'll tell you the reason why we have this. And the reason leads us to the conversation around continuous integration, continuous delivery, and continuous deployment. So this is the last part I'm going to end up today, because I know there's a whole lot of information that's gone by today and I don't want to overwhelm you. But finally, just understand that, first of all, continuous integration is when the code is continually being merged from the feature branches of developers into the master or the main branch. When you do that continuously, that's continuous integration. You're continuously getting the code from all the different from all the different developers and merging it into the master branch. You have your pull request or your merge request, you merge it to the master branch, and then it deploys to the integration environment, and then you can do some integration testing, okay? But continuous delivery comes when it's time to deploy to environments. It could be, your production, your staging, whatever. One is merging the code to master. The other one is actual, deployment to an environment. When you have to click a button to deploy, that's when there is continuous delivery. But when there is no need to click a button to deploy, then you are practicing continuous deployment. So that means from the time the code is pushed, and then the pipeline triggers, and then you build, you test, you do all of that, and it just goes straight to production without anyone manually interrupting it to say, oh, maybe deploy or not deploy or cancel or whatever. It just keeps going. But obviously, it won't release to production if any of the stages fails. But as long as there is success, green all the way, then it just goes straight into production. That's when you're practicing continuous deployment. So let's see continuous delivery in action, okay, from the pipeline. And that way, you would then appreciate all of these things, in totality. So the Jenkins file says here, only build when there is a tag. The reason is because the tag is the part where we version and we create version numbers, version 1, 0, 1, whatever, okay? So that's the tag. And this other part is where continuous delivery is happening, where it waits for you to go in and click on deploy. So let me show you that in action, okay? So what's going to happen is we have to build from a tag. So a tag is a version number that has been given, a version. The other ones don't have version numbers. And the reason you don't want to deploy from master to production is because master is not a version. Well, it is a version, but it's actually not a tagged version, because you can merge your code to master today. Tomorrow you merge to master again. And imagine if you deployed to master yesterday, today you also deploy to master. How do you differentiate between yesterday's master and today's master? But if you're deploying based on versions, you can actually deploy version 103 today, 104 tomorrow. If there is need to roll back, you can basically just go back and deploy 103. And that way you can know the differences between, the version of your code. So let's run this version 104 and see what happens. you would see that by the time it gets to building the software, unit testing, quality gauge, it will skip to develop to environment because there's no need to go to environment because now this has gone through multiple stages from feature branch to master branch. Now it is tagged, so there's no need to go to all those other environments. It deploys to pre-production, but when it gets to production, it doesn't automatically deploy. It will hang in there, wait for 10 minutes because that's what we configured. And within 10 minutes, it will wait for you to decide whether to deploy to production or not. If after 10 minutes, nothing happens, it cancels the pipeline and nothing happens, it doesn't deploy to production. Okay, and you can decide whether you want to deploy to production or not. So as you can see it has done all of that. It has deployed to pre-production because pre-production can be your staging environment. Like I showed you here, this staging, that's our pre-production. That's like the environment before production where we can do like our final review, looking through everything, test it. Is everything working perfectly? All right. And then you can, once you're happy with what you see in your staging, you can come here. It says there wait for interactive input, deploy to production with a question mark. You can either abort or deploy. And that is what we have configured here. Deploy to production with a question mark. All right. That is exactly what you're seeing here. And then I can click on deploy and whatever change we want goes into production. And happy days, our customers will now begin to see the latest change. So if that change was, whatever, we go to Dario.io, the website, maybe we've just introduced a new course or something, you can log in, you will see the new course there, and that's how it works. So this is basically DevOps from a very high level. There is so much in between, there's so much that can happen in between, but trust me, it is basically, what it's all about. I hope this makes sense to all of you, and I hope you're not confused or overwhelmed. Any questions? So I'm going to stop sharing now and just wait for you guys to, ask questions if there are any questions you have, and we can talk about it. If not, then, I'll say we'll end this here today. But of course, during the week, I would encourage you to carry on with your projects, carry on learning your Linux, carry on doing, all that, because in about 2 weeks' time, we're going to start with AWS. If you can get yourself quickly to watching AWS videos, then that will be fantastic.